let's start. So yeah, we are going to talk you first about the speed up, then about some things we added to net train to extend the possibility for training. Then also parameterized net model, which are kind of factories of a network which are not initialized. Like net model up to now, it was a pre-trained model, already trained model, and now we extended the capability to add some parameters. Then we'll talk about the new layers that we did. So we extended some existing layers and added new ones to be able to implement state-of-the-art architectures like capsule networks and transformers. And finally, we'll talk about byte pair encoding, which is a hot stuff for translation. So first, we gain some speed up for RNN on CPU. So for example, this command, which used to take half a second in version 11.3, now yeah, it's five times faster. So yeah, RNN are much faster on CPU. Also, now there will be the possibility of doing multi-GPU. Like before, you could do target device, go to CPU or GPU. And if you had several GPU, you can specify which GPU you want to use. And now if you put all, then you could do a multi-GPU and have very fast training then. Also, we are supporting Tensor Core, which is a special architecture of GPU, which are doing very fast multiplications. So it's working in mixed precision, 16 and 32 bytes. And for example, here we see the benchmark on speed up on some classical architectures. So you see that it can be 3 times faster on VGE, for example. And so yeah, it's a big speed up for convolution and also recurrent neural networks, everything that involves matrix multiplications. Also, we are supporting numeric arrays. So I think there is a presentation right now on numeric array, which is a new format to represent in a compact form matrices rather than having lists of lists. So we are supporting this. So yeah, numeric array, if you do normally just a matrix. And also with the option working precision, you can choose to work in either 32 or 64 bits. So now it's making the neural networks a real scientific framework. It's much more efficient, and you can choose the precision that you want for computations.
So was numeric array made to support the neural networks, or it's the other way around?
It's the other way around.
Yeah, it's neural network supporting numeric array. So you will be able to send numeric array directly into it and to do some computations. Because in neural networks, we are operations that are not necessarily in Mathematica, so it can be convenient also to use it to handle numeric array.
Yes, because it's more compact. I mean, the numeric arrays are like bringing like C-style typed arrays into top level as a first-class citizen of the language. And so it has some advantages. Yeah, but you can specify the type. You can have integers and ones.
Okay, now let's see what we...
Sorry, Jerome. The main advantage is usually memory. Because prior to this, all floating-point numbers in top-level lists were only 64 bits, and that's it. While in deep learning, usually you usually don't want to go above 32. So you get lots of memory. Yeah, I mean, you get much less memory usage, and also, for example, for integers, like for semantic segmentation, which is you can classify every pixel. You have these masks in which, for every pixel, you have an integer, which tells you what class does it belong. And also, prior to that, every single one of those integers were 64 bits. So while you can, as long as you have less than 256 classes, you can do with 8 bits. So that's I mean, you get a lot into memory consumption.
So now let's see what we added to NetTrain in order to make NetTrain yet a higher level, more higher level function. So yeah, this is not fully implemented yet, but we will have this option training measurements. where you can, it's like classifier measurements, like you can, there is a full list of measures that you can have on classification, like F1 recall precision, also macro recall, macro precision for those who are familiar with this kind of measures. So basically all the things that are in classifier measurement are going to be there. So for now, it's not plotting where it's not plotting yet when I'm training, but here we should have the curves of the recall, the precision, and the F1 score here.
Can you stop it?
Yeah, but if I stop it,
It'll be smaller.
wait.
Yeah. Okay.
Wait a moment. Yeah, just to show that it's then it's one of the output probability that you can ask for the validation measurements. So all the measures that you ask also will be there, like for your final net, and you can also ask the values on the training set. It's called round measurements. So you say here is for each class the recall and the precision, because it's multi-class classification. Here is fashion MNIST, which is small images of fashions, and you have 10 classes. And so, yeah, you've got the classification measure for all the classes. Also, early stopping. So early stopping is very useful when you perform long training and you don't want to monitor each day to see where is your training. So you want to stop automatically where the network stops improving on the validation set. So there is an option now, training stopping criterion. So I can demo. So I have some data like this. And here, for example, I ask to stop when the error rate is not improving for 50 rounds. So we can check here. Then yeah, it's up. The minimum is around here. Do you see my mouse? Yeah. The minimum is around here, and then we stop five rounds after. So we could also specify a loss. And there are more parameters, like instead of talking about strict improvement, you can say, okay, let's stop when the relative improvement is less than the ratio, and then it will take this into account also. Okay, there are also some new properties. So I remind that the third argument of net train, you can ask properties. So by default is the trained network, but you can ask for all the classification measures or the loss during the training. And now you can specify some association like this. And here, for example, I'm going to ask for the batch losses. I'm going to ask for a plot of this and to sample it every batch. And I can also ask for the root mean square of the gradients. So it can ease the debugging. Like if you launch your training and suddenly it's diverging, and maybe it's on a particular batch, for example, when there is an enormous sequence, then with this kind of plots, you will be able to detect anomalies, this kind of stuff. So yeah, this kind of utilities for debugging. Okay, so we also unlock the possibility of doing reinforcement learning and active learning, all this kind of stuff. So yeah, we integrated the OpenAI gyms. So it's to do some proof of concept of on reinforcement learning. So it's using device open to do it. So yeah, reinforcement learning basically, the net is giving some policy to take some the next action given the state. So all the previous action that was taken. And so the particularity is that you need a reward. So the environment is your data, but it needs to interact with your network. Like the data that is going to come at the next round depends on what happened before and what answers the network. So you need this feedback between the network and the data. And so basically the unlocking consists in giving access in the data generator. So because I remember that in NetTrain, you can give some data preloaded in memory, like arrays goes to labels, but you can also build a data generation, which is a function that generates your data. And now inside this data generation, you will be to access some properties of the training, including the network. And here I do, so yeah, there will be some tutorial. soon on the reinforcement learning to explain how to do it. And here I will start demo another stuff, which is active learning. So active learning, it's when you want to split the training and then to focus on the examples that are hard. Like if you see that you are classifying well one examples, then you are going to downweight them. So what I'm doing here, I define a data generator, which is partitioning the data into batches, and then by default assigning equal weights to all the data. And then I'm going to access in my data generation the batch loss, and which is the cross entropy. And depending on this cross entropy, I will give some weights for to sample the next data to give to the network. And to check that it works also, here I'm appending into a list this batch loss. And so you didn't see each training, sorry.
Maybe there's a question.
Yeah, I was just curious.
No.
So what percentage of the new functions or functionality that you're adding is stuff that you found to be useful versus, I mean, you go out and kind of cull the research and take the stuff that seems to be the hottest and put it in the software? Or are you guys also generating some of the new algorithms and frameworks, or how's that work?
No, we are more for, looking at the state of the art, at the last papers, and when.
Working with the industry more?
Yeah, in the academy also, like the novelties come from the academy. So for example, now in deep learning, reinforcement learning and GANs, generative adversarial neural networks, are very hot. So this kind of stuff, when we see that, when we judge that many people are using it, then we say, okay, we need it, basically.
What is unique to Wolfram is the decoders and the encoders. Most of the other systems don't have such a selection.
Yeah, the pre and post processing are inside the network.
I would say that we follow the literature for the to look at the applications that we actually need to support, but then the design to actually build the tools to support those applications is genuine, because our framework is a much higher level than other frameworks. So I mean, its goal is to be easier to use, and you don't have to write. You usually have to write like much less code to do stuff in our framework than in other frameworks. And so like the design in which we actually come up with how to add these tools to the frameworks is mostly original, because our framework is very different from other frameworks usually. Like for example, those training measurements in NetTrain, like basically no other framework has NetTrain except for Keras. So this is an example of the framework being much higher level. So
Keras was ported to R, and so R is very similar to mathematics in many ways. So
yeah.
There are some features.
Yes, fair enough. That's true. Sorry? Yes, but yes, we use MXNet in the backend, but our framework doesn't look anything like MXNet. I mean, you can see the entire framework as a very sophisticated wrapper over MXNet, but MXNet is completely hidden. Like all the complexity of dealing with MXNet, it's much simpler to use. So all the design is original.
So in principle, you can change MXNet. You can use some.
We are
In
contributors
principle,
of MXNet. Like for the layers we will
Yes,
present,
yes.
we added some things that
but
are
maybe
missing.
he meant we could swap the backend with something else. In principle, yes, but it would require months of work. But in principle, yes.
Well, I mean, Wolfram research is collaborating with them.
Yes. We contribute to MXNet. Yes. So parameterized net models. So the initial motivation for these was that we already have many models in the neural network repository, which belong to the same family. Okay. So for example, there are 3 ResNet models trained on ImageNet, the original ResNet models. So it would make sense to have something like this, wouldn't it? You call net model of ResNet, type goes to whatever. So this is how this thing was built. And there will be many parameterized net models coming from 12. These are some of them. So we get, okay, I will actually, well, in principle, I would have demoed this thing, but I will just show you a screenshot of this running. Okay, these are some example of some parameterized net models which are coming in the repository for 12. So the first example will be sketch-RNN. So sketch-RNN is a, let's actually, okay, this was supposed to be a link.
I think we're over time. You can skip
Yeah,
it.
okay, fine. So let's look at one of the first parameterized net models. Wait a second. No, there are more. Okay. There are more screenshots. Okay, fine. We will skip this. Okay, okay. So this was example 2 of parameterized net models, self-normalizing network. So so sketch-RNN was something like you have a family of models like ResNet I showed you before, and you can pick a particular pre-trained one. But the parameterized net model paradigm allows you also to basically generate architecture on the fly. What is happening here? It's going worse and worse. Oh, okay, fine. I like this. So you can pick individual pre-trained models with a parameterization paradigm, but you can also generate architecture on the fly with parameterization paradigm. So this is how the API for the parameterized net model would look like. So the CelluNet is the self-normalizing nets. This is an uninitialized model, and it's basically a factory of architectures. Okay, so there are parameters. Here we have depth and width. You can query these parameter information, return a data set with all descriptions. And you can generate this architecture on the fly with calls to the parameterized net models in this way. So you get first argument is the name of the model, and then you get all the specification for the parameters, and boom, you get the individual net chain. So this would be a net chain with depth 5, of width 32, with dropout probability of 0.3. And you also get defaults and so on. So yeah. So this makes for the parameterized net model API. So should I do BPE or should you? No, it's probably you should keep going. Yeah.
Nice. I think it's still you.
Oh, okay, that's still me. Yes. Yes. It will be in the repository. Well, when 12 goes live, the model will show up on the repository. Yes.
But how we can use the cell whatever layer.
Yes. It will be fully available as well. Okay, so now we also had some extension and improvement of existing layers. So for instance, reshape layer will now accept the automatics and inherited specification. So reshape layer is, as you have guessed, it reshapes an input tensor to some target shape, just like array reshape does. So we have now added the automatic and inherited keywords in the specs. So automatics will infer a single dimension from the product of the others so as to keep the same size, and inherited will just copy the dimension. So for example, here, I can specify to copy the first dimension, which is varying, so it will be still variable length. And I can infer these automatically, and I specify these to be 2. And so the automatic will generate correctly a 4 here so as to match. They are very useful because they will fully integrate with our reshaping engine, which is done through net replace part and changing the input shape. So previously, if you get something like this, which would output a size of 8 by 3 by 2, and then you change the input size, you would get a mismatch between the product of the dimensions of input and output, and it would just fail. But by using automatic and inherited, it will just work and reevaluate itself. So this is very handy to change the input size of the networks which have these reshape layer inside them. So we've done improvement to convolution, deconvolution, and pooling. So we have finally supporting the so-called group convolutions with channel group parameters. So this was an old functionality that's old for like the deep learning world, at least, originally appearing in Café. Sure. This was mainly introduced by AlexNet.
You have to be this guy.
In order to overcome GPU memory limitations. But now it has risen back to popularity because you sacrifice some expressiveness, but you get much faster evaluation time. And so there is this very popular architecture, which is coming as a parameterized net model, by the way, which is called MobileNet, which is a lightweight convolutional network which uses this. And so now we can specify the channel groups, both in convolution and deconvolution. Then, well, other minor things like one-dimensional deconvolutions and asymmetric padding specification. So previously we could do asymmetric padding by using padding layer, but now it's also built in the framework. So this means pad by 3 zeros on the left of axis 1, 1 0 on the right of axis 1, and so on and so forth. And this is fully integrated with also the variable length support and the interleaved convolution, which bring the channel dimension at the last. So it's a nice addition. Okay, so capsule nets, but there's probably no more time. How much time do we have? None. Okay, not fine. There was a lot of new stuff in the framework, as you've seen.
No, we should at
You
least.
should what?
I don't know. CapsuleNet, yeah, so it's a hot stuff proposed by Inton, like a new paradigm in the neural network. So yeah, we were missing some kind of pieces. Like in 11.3, it's available but with the MX layer, with kind of hack to do some MXNet code inside the layers. So we don't need it anymore. And also hot stuff is the transformers.
Yeah.
Which is for translation. Like now it's the state of the art for all the translation models use it, and it's not based on recurrent neural networks. So LSTM has existed for 10 years, and it was no architecture has beaten it. And here it's a new architecture based on attention. So I don't have time to explain, but we already had an attention layer that was there, and we extended it to be able to implement the transformers with some. Yeah, so there is the attention layer and also the
Layer normalization.
layer normalization. Yeah, we had a layer called instance normalization before, which was doing this stuff here, and now we are able to do layer normalization. So yeah, now the layer is called normalization layer, and with a lot of parameters, you can.
It's basically become a general layer which can reproduce instance normalization and also batch normalization, I think.
No, batch normalization is different.
That is coming, but yeah, it's a big generalization of the instance normalization layer.
Yeah, exactly. So yeah, now there are pre-trained transformers that are going to be also in the repository. And also for the encoding part, so we wanted to talk, but we have no time, about BPN encoding, which is a kind of tokenization that groups tokenize in subwords. Yeah. That is state of the art for the translation. So sorry about the overtime and the issues. Thank you.